Hi students, welcome to Sunil's tutorial. I am Sunil Milwani and today we will be doing this chapter of physics called as current electricity. Now, we all have learned Ohm's law. Right? We all have learned Ohm's law in our school. Ohm's law states that so long as the physical state of the conductor remains the same, so long as the physical state of the conductor remains same, the potential difference applied across the ends of the conductor there is a constant ratio to the current flowing through the conductor. Ratio to the current flowing through the conductor. What does this mean? Right? Ohm's law. What does this mean? It means that, as in simple language, if I have a circuit, as I increase the number of batteries, more current will flow. As the number of batteries applied go on increasing, the current goes on increasing. So long as the physical state of the conductor remains the same, so long as I don't heat it, cool it, I don't do any of such things, so long as the physical state is not changed, the potential difference applied across the ends of the conductor, that means how many batteries are connected, will determine how much current will flow, right? That means Ohm's law states that potential difference is directly proportional to current. V is equal to Ki, where K is a constant. Right? V, since it is a constant, I can give it any name. I will call it as Ri. Therefore, I can say R is equal to V upon I, where R is called as resistance. Right? What is the unit for resistance? Resistance, potential difference is measured in volts, current is measured in amperes. So, therefore, I can say that the unit of resistance is 1 volt upon 1 ampere. 1 volt upon 1 ampere is called as 1 ohm. How do I define 1 ohm? When a potential difference of 1 volt produces a current of 1 ampere, then the resistance is 1 ohm. What is 1 ohm? Ohm is the unit of resistance. Fine, do we get this in clear? This is the SI unit of resistance. Next. Question. Sir, you've written this law, you've called this word R, you've changed K to R and you called it as resistance. Why resistance? I could have named it anything else. Why resistance only? Let us see the concept of resistance. Now guys, all of you please see this. Let's assume that I have a conductor, I have a wire under a microscope. I will show you a wire under a microscope. Now, we know that every element is made up of atoms. So there are these atoms here. I'm going to draw the atoms in black. At random, these are atoms. These atoms have electrons. Okay. Now, when potential difference is applied to the wire, that is to the conductor, this is the positive terminal, this is the negative terminal. When potential difference is applied to the conductor, the positive terminal attracts all the electrons. The positive terminal, we know that opposite charges attract each other. The positive terminal attracts all the electrons. As it attracts all the electrons, these electrons start to move towards the positive terminal. Right? We will show the electrons with red only. These are these dots. Let's assume that these dots are electrons. These electrons try to move towards the positive terminal. As they try to move towards the positive terminal, they collide with the atom, because the atom is so big, the atom is in the path of the electron. They collide with the atom, they rebound, and then they move ahead, right? That means free movement of electrons is not allowed. There is some opposition to the free movement of electrons. This opposition to the free movement of electrons is resistance. That is how the concept of resistance was developed. What is resistance? Resistance is the opposition to the free movement of electrons. As these electrons move, they collide against the atom. They give their kinetic energy to the atom. Hence, atoms start vibrating with a larger amplitude. That is one of the reasons why the wire gets heated when current flows through it. Okay? So as the electrons move, they collide against the atoms. Right? That means free movement of electrons is not possible due to the presence of atom. And this opposition to the free movement of electrons is called as resistance. This is the concept of resistance. Do you understand why we have resistance? Right? Next, let's see. So do you understand the concept of resistance? What is resistance? Resistance is the opposition to the free movement of electrons. Right? Due to the presence of atoms. Right? This opposition to the free movement of electrons is called as resistance. And that is the reason why in Ohm's law I have called it as, or he has called it as resistance and not something else. Fine, do you get this thing clear? Now, point number 3. It has been experimentally found. It has been experimentally found that resistance is directly proportional to the length of the conductor. As the length of the conductor increases, resistance increases. Question: why? Very simple logic, guys. As the length of the conductor increases, electrons will have to cover a larger distance. Larger distance means more collisions with the atom, therefore greater resistance. It has been experimentally found out that resistance is inversely proportional to the cross-sectional area. Resistance is inversely proportional to the cross-sectional area. Question: why? As the cross-sectional area increases, the free space available for the movement of electrons will increase, right? Hence there will be less collisions and hence there will be less resistance. Therefore, I can say that if I join the two equations, R is equal to L by A, to convert proportionality to equality, I have to multiply by constant. Therefore, I can say R is equal to rho L by A, right? Where rho is the constant of proportionality and is called specific resistance. Rho is a constant and it is called as specific resistance. Therefore, rho is nothing but, if I cross multiply RA by L, if I cross multiply A here, I'll get rho is equal to RA by L, resistance into cross-sectional area upon length. What is specific resistance? Specific resistance is the resistance of the material. Every material has a typical opposition to the movement of electron. That is the characteristic feature of that material. Like, every individual has an inherent property. We can breathe, that's an inherent property. Similarly, every material has an inherent property that it will offer X amount of resistance to the current. which is due to the material, and that is called as specific resistance. What will be the unit of specific resistance? Unit of specific resistance. Specific resistance is RA by L. We know that resistance is measured in ohms, area is measured in meter square, length is measured in meters. Cancel. Therefore, the unit for specific resistance is ohm meter. The unit of specific resistance is ohm meter. Fine, do we get this in clear? How do you define specific? Yes.
So why we are using rho instead of k?
You can use, I've already used k constant at different places. So every equation has to have a different constant, right? How do I define specific resistance? If the resistance of the wire is 1 ohm for a cross-sectional area of 1 meter square, and if the length of the wire is 1 meter, then the specific resistance is 1 ohm meter, right? Do we get this in clear? So once you have, this is what is specific resistance. Now, it has also been found out, let us assume that R0 is the resistance at 0 degrees centigrade. Let us assume that R0 is the resistance of the material at 0 degrees centigrade. Let us assume RT is the resistance of the material at T degrees centigrade. Right? When you heat the material, the length will increase. When you heat any substance, its length increases, and we know that resistance is directly proportional to length. As the length increases, resistance will also increase. So, how much is the increase in resistance? The increase in resistance is nothing but RT minus R0. How much is the increase in temperature? T minus 0, that is T degrees centigrade. Now, it has been experimentally found out that the increase in resistance is directly proportional to the initial resistance. The increase in resistance is directly proportional to the initial resistance. The increase in resistance is directly proportional to temperature, the rise in temperature. The increase in resistance is directly proportional to the rise in temperature. Therefore, I can say that the increase in resistance is directly proportional to R0T if I join the two equations. Now, I can therefore say that if I convert proportionality to equality, here again I will use a different constant, right? So I can therefore say that RT minus R0 is equal to alpha times R0T. I am using the constant as alpha, right? Where I can say that alpha is RT minus R0 upon R0T, right? Where alpha is nothing but the temperature coefficient of resistance. What is the temperature coefficient of resistance? It is the increase in resistance per unit resistance per degree rise in temperature. What is the temperature coefficient of resistance? The temperature coefficient of resistance can be defined as the increase in resistance per unit resistance at 0 degrees centigrade per unit rise in temperature, right? I could also say from this equation also RT minus R0 is alpha times R0T. Therefore, I can say that RT is R0 plus alpha times R0T minus R0. When I take it on the other side, will become plus R0. Therefore, I could say that RT is equal to R0 1 plus alpha T. Fine, do we get this in clear? This shows the temperature dependence of resistance, meaning it shows that the resistance changes with temperature. Right? Do we get this in clear? Now, there are certain resistors which are built in such a way that there is a large change in their resistance with a small change in temperature. Such resistors are called as thermistors. What are thermistors? Thermistors are nothing but they are thermally sensitive resistors. What are thermistors? Thermistors are thermally sensitive resistors, right? Wherein a small change in temperature brings about a large change in their resistance. Question: how will it bring about a change in the resistance? Will it increase the resistance or will it decrease the resistance? We have two types of thermistors. Thermistors are further classified into two types: positive temperature coefficient thermistors and negative temperature coefficient thermistors. Thermistors are classified into two types: positive temperature coefficient thermistors, which are also referred to as PTCs, and negative temperature coefficient resistors, which are referred to as NTC. What are positive temperature coefficient resistors? These are resistors where the resistance is directly proportional to the temperature, meaning as the temperature increases, the resistance also increases, right? How do I represent them graphically? I could draw a graph that would show me I could draw a temperature versus resistance graph, where as the temperature increases, the resistance also increases. As the temperature increases, the resistance also increases. Fine, do we get this in here? You also have negative temperature coefficient resistors. What are negative temperature coefficient resistors? These are resistors where the resistance is inversely proportional to temperature, meaning as the temperature decreases, the resistance increases, right? As the temperature decreases, the resistance increases. These are called as negative temperature coefficient resistors. How do I represent them graphically? Graphically, if I draw a graph of temperature versus resistance, the graph would slope downwards from left to right, right? Example of positive temperature coefficient resistors: your iron, steam iron, what you use for ironing the clothes. As the temperature increases, the thermostat switches off and the iron switches off, otherwise your clothes will catch fire. Example of negative temperature coefficient resistors: AC. As the temperature falls below a particular level, the compressor switches off. Right? Do we get this thing here? Now, how does a resistor look like? Resistors are generally cylindrical in shape. Resistors are generally cylindrical in shape. They have two leads for connection. They have a ceramic body. So this is their ceramic body, which is cylindrical in shape. These are leads for connection. Now, if this is what a resistor looks like, how do I find out what will be its resistance? In order to enable an individual to find out what will be its resistance, there are 4 bands on it. There are 4 bands on it. This is the first, second, third and fourth. These bands have been given different colors. Based on what is the color given to them, you can find out the value of the resistance. The value of the resistance can be found out on the basis of the color of the bands, right? How do I learn this, guys? How do I learn the band colors? You can learn this way. Listen to me carefully. B.B. Roy of Great Britain had a very great wife in gold, silver and no color. BB Roy, that's the short form to learn the colors. First I'll show you the short form and then I'll tell you how the colors are. BB Roy of Great Britain had a very great wife in gold, silver and no color. BB Roy of Great Britain had a very great wife in gold, silver and no color. Now what are the colors here? Black. You have black, brown, red, orange, yellow, green, blue, violet, grey, white, gold, silver and no color. No color means there will be only 3 bands present. Now depending what is the color given to that band. First band, second band, third band or fourth band. If the color is black in the first band, then its value is 0. The values are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. The first band could take only these colors up to white. It cannot have the color gold, silver or no color. Second band also 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'll show you how to read this. Third band, give me a minute, I'll just show you how it is. For third band, if the color is in the third band, that is called as the multiplier band. It will be 10 raised to 0, 10 raised to 1, 10 raised to 2, 10 raised to 3, 4, 5, 6, 7, 8, 9. Fine, do we get this thing here? Now, if it is gold, gold, silver and no color is given to the fourth band, which stands for plus minus 5% tolerance, plus minus 10% and plus minus 20%. This shows the extent to which the value of resistance will change, is subjected to change. So whatever you calculated plus minus 5% it could be, right? Now, how do I use this? Guys, let's see this. How do I use this? Suppose if they give me, fine guys, please pay attention here. Suppose if they tell me red, yellow, orange, silver. If they tell me to find the resistance for the color code red, yellow, orange and silver. Guys, see this, how do I do this? Red, from the table we know red is 2, yellow is 4. We know that the third band is the multiplier band, so you put a multiplication sign. Orange is 10 raised to 3. The fourth band is the tolerance band. Silver is plus minus 10%. Therefore, the value of the resistance is 24 into 10 raised to 3. 24,000 ohms plus minus 10%. That's how you find the value of the resistance. See, I'll show you another. Suppose if I have violet, green, red and gold, right? Violet value is 7, green value is 5. The third band is the multiplier band, and red is 10 raised to 2, gold is plus minus 5%. So the value of resistance will be 7500, 75 into 0 ohms, 7500 plus minus 5%. Right? That's how, just by looking at the color band, you can find out what is the value of the resistance. Fine, do we get this thing clear? We will stop this here for the day. Thank you very much.